So let's see the different ways of joining. First, like we said, is a Cartesian product. Now, what is a Cartesian product? It is formed when a joint condition is omitted, or a joint condition is invalid, or all rows in the first table are joined to all rows in the second table. Okay, so to avoid a Cartesian product, always include a valid joint condition in a where class. Okay, so what is Cartesian product? If you see in the employees table, we have 20 rows, and department tables, we have 8 rows. Now, a Cartesian product is nothing but 20 into 8 rows, which is 160 rows. And what does this mean? Each row of employee is joined to each row of department. So if you do a Cartesian product, then King works in administration, King works in marketing, King works in shipping, King works in contracting. Same way, Kochar also works in administration, marketing, shipping, contracting. So basically, what it says is the story which is formed is each of the employee works in each of the department. It is wrong, right? But this is called Cartesian product. Okay. Now, this is also sometimes needed. There will be some cases, though it is a very rare case, but there are cases where we have to do a Cartesian product. Okay. Now, let's see how do we put a joint conditions. Now, this is Oracle joins. Okay. Where we just put the select. So if you see, we have the table 1 dot column, table 2 dot column, from table 1 comma table 2, where table 1 dot column 1 is equal to table 2 dot column 2. So this is nothing in where we are putting the matching condition. Okay, that means if the values of the column matches, then you join them. Write the join condition in the where clause. The join condition is in the where clause. Prefix the column name with the table name when the same column name appears in more than one table. Now, what does this mean? Whenever you are joining and you have the same column name in both the tables, you need to tell from which table you are referring this column. Okay, so for example, if this is a column, okay, and this is same in both the tables, table 1 and table 2, so we need to write table 1 dot column and table 2 dot column to indicate that this column is coming from table 1 and this column is coming from table 2, even though the column names are same, right? And this also is applicable if you are doing this join in this column where it is same. Right now, if column 1 and column 2, the names are different, it is not necessary that you need to put the table name before the column name, but it is always advisable that you should do that, so that your code is very clear and very neat, and people can just look at the query and they understand that, okay, this column was taken from this table. Okay, this is very important. Okay, so now next what we'll see is an Equi Join. Okay, what is an Equi Join? You see, this employees table is has a department ID, and the department table has a department ID. Now we have a foreign key and a primary key relation. Let me quickly describe what is a foreign key and what is a primary key. Right? So foreign key, so a primary key is nothing but a key which uniquely identifies the rows in the table. Okay. Also, a primary key should be unique. Like I tell, you can't repeat primary keys, and there can't be any null in a primary key column. Okay, there can't be any null. Whereas in foreign key, the values can repeat, right? The values can repeat, it can have null. Okay, but the only condition here is this value should be a subset of the primary key. Foreign key should always be a subset of the primary key. That is, the range of this value should be actually already present in departments. If I am putting a department ID which is not already present in departments, employees will throw an error. That see, you are trying to insert a record and a department ID which the department ID is actually not present itself in the main table of departments. It will throw me an error. Okay, so how do we put this? Let's write the query. Select emp dot employee id emp dot last name emp dot department id. Okay, department id. Then we have dept dot department id and dept. Okay, just remove this. Dept dot department name from employees, HR employees, and let me select HR departments also now. Departments, and let me name them. So HR employees can have the name of EMP. Okay, HR departments can have a name of DEPT. Okay, where EMP dot department ID is equal to DEPT dot department ID. Okay, so what we are doing now is we have joined both the tables on the department ID. Okay, so what we are getting here is now the department name for each of the departments. If we want, we can also skip one of the departments here, not needed, because obviously if they're same only, then it comes. What happened to this? Okay, okay, now this makes more sense. Okay, so this was about equi-join, where only if the values are equal, then we get the row. Then the row is written. Now, along with this, what we can also do is we can have additional join conditions using the AND keyword. Okay, now we have already learned how to use AND keyword. So what I can do is I can put AND last name is equal to okay. So I get for Matos, I get the department name and whatever data I need. Okay, so this is how you can use. Now, if you want to have other tables, okay, if you want to have the location also, because department ID, if you see, departments has department name, which we just now got. It has location ID as well. Now location ID, you won't get an employees table, so you can't join employees to location directly, but you need the departments table to join. So we have already joined departments table. What we now need is to join the locations table, and we get the location as well. So let's pull first locations LOC dot city, and here I'll add HR dot locations where employee department and DEPT dot location ID is equal to LOC dot location ID. What happened to this? I think this should be correct, right? Look, see it, okay, I didn't put the name of LOC. Okay, now it works. So see, whenever there is a location ID match, that is when we get the city also. Okay, so now we are getting the employee details, the department details, and the city details in a single output. So this is the magic of joins, where even though our data is distributed across multiple tables, that is how tables are in RDBMS, and the all the major databases right now are based on RDBMS, right? And what we do, even if it's not based on RDBMS, when we are finally querying it, our interface at least is made in such a way that we think that our data is in RDBMS format. Okay, because nowadays databases are very advanced. Databases are stored in various formats, right? The text file format, NoSQL format, and there are many other formats. But at least when we query, we get this view of an RDBMS view. Okay, so coming to the point where we were, so locations we pulled, this is a new table which we pulled, and we made a join on a department and a location. So it's now employee joins to department and department joins to location. So this way we can join employee and the location as well, because department ID was the common bridge. Okay, and from location table we picked up city. So this is how we can get data from multiple uh, tables together. Okay, moving ahead. So next what we see is the non-equi join. Okay, now what is a non-equi join? Sometimes what happens is we don't want to have a direct join. Okay, so we don't want a salary to have a direct join our salary, but we want what we want is that it should be somewhere in the middle of it. So if a salary which is for example 4,200, right? So it falls between 3,000 and 5,999, right? So I want the grade to be shown as B. Okay, so if I want this kind of a join, this is called a non-equi join. Okay, so how can we do this? Do we have, okay, so we have a job ID here and we have the minimum salary and maximum salary. What we can do is we can write a non-equi join on this. Let's try this out. Select the employee ID and this jobs table, job. We don't need one more. Okay, and let's get the job title based on not the, we will not now join on job ID, we will join on minimum salary and maximum salary. So let's get the job title, job title. Okay, from HR jobs where emp dot salary between job dot min salary and job dot max salary. Okay, let me even pull out the salary also, so it will be easier. So let's have emp dot salary, what we pick from employee, and from job we pick job dot min salary. job dot max salary. Okay, now let's see. Okay, so you see this salary from which we are picking from employee, this is between this salary, right? Then 2200, this is between this 2008 and 5000. Let's go for some other salary. Okay, this one 2600, that is between 2500 and 5500, right? So this is how we can get, we can join between two columns. So this is not an equal join, but then it is between the range, right? So hence we call it as a non-equi join. Okay, then we'll see next what we have is outer joins. Now outer joins, so there are different kinds of joins, right? So we learned equi join, non-equi join. Now outer joins, we have a left outer join and a right outer join. Earlier we used to write it in this manner. Let me just show it to you really quick. Okay, so if in case this was our tables, right, and I wanted all the columns from my employee table, because this is employee, right, and this is department. So I want all the rows from my employee table to come in, and only if there's a corresponding match in department table, then only get me that value, otherwise don't get me the value. That means if we are doing an equal join, if this value is present in both the tables, then only we get the row, right? If that value is not, if a value is not present in either of the table, we won't get the value. That is what equijoin is. But in outer joins, if the value is present in one of the tables which we are specifying, then we can get the value. If it is not present in the others, still it's fine. Okay, so if we put a plus here, okay, now it becomes a left join, which means all the rows from this table, that is the employee table, should come, and the corresponding matching rows from department should come. If there is something which is extra in employee table and it is not present in department table, it is still fine, but then that should come in. Now again, I should remind you that this is an old way of writing. Okay, this is an old way of writing of joins. We soon, like in some time, we are going to learn how to write the joins properly. So this is the syntax which we will be learning in some time. Before that, there is a very important concept which we generally get at work and we generally get at interviews. This is a question itself which is generally we get. Okay, so it's a very important one. Understand this, self join. Now let's go to our data. Okay, if you see, for each row we have the employees, right? We also have a manager ID. What is a manager ID? A manager ID is nothing but the employee ID of another employee, right? And that employee is the manager of another employee. For example, if we go for this 130 employee, which is Atkinson, so Atkinson's manager ID is 121. Now if I go to 121, I see that 121 is Adam Fripp. So Fripp is the manager of Atkinson, right? Right. How do I get the name of the employee and the name of the manager in a single row? How do I do that? Because we don't have another table as such, right? Where we have the manager ID and the manager name, right? We don't have it. Everything is in the same table. So how do we do that now? So that is when self joins are used. Okay, that is when self joins are used. Let me show you how we can do it. Select worker dot last name works for okay. So now HR employees, one of them will be worker. Let me write the query and then I'll explain you how this is working. Okay. So now what we have, bait works for Cambron. Let's check if that's true or not. Okay. Let's see where is baits. Okay, baits, and we have Cambron. Let's check them out together. Okay, Bates work for Campbell is true. Elizabeth, 148. Right, 148 is none but than Campbell, right? So we are getting the correct data. Now, how did this work? What we actually did is we took the same table and we joined it with itself only. Okay, because data is in the same table, right? Data, the manager data is also in the same table. So we took the two tables and we joined them together. Now, because how I checked this now, I went to the employee, I picked up its manager ID, right? So for the worker, I picked up the manager ID. That's what I'm doing here. For the worker, I'm picking up the manager ID, and then I am searching for this ID. Okay, once I got it in the table, I search for its last name. So for the manager, I search for the employee ID. And this is how I do a self join. This topic is a bit confusing, I understand. So if there is a difficulty for you to understand it in the first place, try executing this query and try and repeat the recording again so that you understand exactly how this is working. Okay, so this is how self join works. Now let's come to how actually joins are written nowadays. So whatever, writing with a comma and writing a plus sign, these are old school writing of queries. And right now also sometimes you will get, so if you go to big organizations which had queries written from many years, you will get such queries where you have plus written to indicate a left join or right join. But nowadays everyone uses this syntax. Okay, so let's see. So cross join, the one you see, cross join is nothing but a Cartesian product. Natural join is nothing but an equi join. Okay, same join, the natural join or an equi join we can do using the using column. Same thing we can do by specifying the column names. Okay, then we have the left, right join or full outer join. Okay, this is the one which we did with plus. Okay, now we will see each of them how we can write the queries. Okay, so let's see. Cross join, as you know, it is nothing but a Cartesian product. Okay, so let's do this. Remember when in this syntax, which is the latest syntax, we don't write the join conditions in where. Okay, we write it differently. So I'll show you that. So let me do a cross join now. Cross join of last name and department name. Okay, now we get many. Okay, now we get many rows. So basically what we are doing is, if you see here, Abel works in administration, Ander works in administration, Atkinson works in administration. Like this, we will have 108 rows where the department name will be administration. So basically, each row of employee table is being joined to each row of department. And that's the reason why we don't need a common column here, because we're not joining on any column, right? It's just a cross join. So see, once administration gets over in 108th row, in 109th row, we have Abel again going for marketing and Andy again going for marketing, Atkinson going for marketing, whether we already had this for administration, right? So basically each row from the last name is multiplied to each row to the departments table. Okay, this is what cross joins is. Okay, rarely used, but sometimes yes, it is used. Okay, next we'll see on natural joins. Okay, now what is a natural join? When you have the same column name in both the tables, you don't need to specify the column name upfront. Okay, that is what a natural join is, because the join is very naturally. Okay, let's see. Okay, so the department ID column is same across employees and departments, so we don't need to put any um, common any column, right? That's the natural join. Remember one thing, when you are doing a natural join, the column name should be same and the column data type also should be same. It shouldn't be that, okay, even the name is same and we know that both of them indicate the same thing, but the data type for some reason, in one it was numerical and in another it was uh, string, right? That shouldn't be the case. Okay, so this is what natural join is. Next we will see joins using the using clause. Okay, using clause. Now here what we will do is we will specify on which column to join. So we'll just remove this join. Okay, this is also kind of an equi join, and the previous one also was equi join. Okay, using department ID. Okay, so using department again is the same. Now we are specifying that, okay, this is the column on which you need to make the join. Okay, this is nothing but your use natural join with the keyword using. Okay, okay, next what we will see is use is with the on clause. Now on, so let me just name it. It will be mpm, it will be dept. So emp dot department id is equal to dept dot department id. Okay, again the same result. Basically both are same, but there we were using clause, here it is on clause, and again this is the equi join, where only if the value is present in both the tables we get the data. Now we move on to the interesting left join and right join. Okay, we will see that. So previously what we saw is whether in whichever side we write a plus, that is the join which we are doing. If we are in left, it's a left join. If it's a right, it's a right join. Now we will specify left join. Okay, now when you specify left join, everything from department ID will come, but only the corresponding matching from the department table will come. Okay, this is actually, if you see logically, this doesn't make sense. Just think why. Pause and think why this doesn't make sense. Now, department ID, the primary key of department ID lies in department table, right? This table. And in employee, the foreign key lies, right? Now, how can that this be a case that we have a department ID in the employee table which is not present in department table, right? It can be the other way around. So if I would have written department on this side and employee on this side, then it might be the case there are department IDs where there are no employees working, and that would have come up in this result, right? So writing in this way, it won't make sense, but yeah, syntactically and everything is it is correct. That is a reason why you should do what you should do is just the way I have done. I have taken a dump in the Excel, okay, of all the data of the tables that I'm going to use, okay, and so these are the tables which I'm going to use and data. And whenever I am writing a query and I know, okay, this is the question, I can just, go here and I can take the question, think about the question, filter out data in Excel and see what all rows I am getting. And then I see if I'm getting the correct rows and the correct number of rows here or not. Okay. You can do this. Okay. So right now we just run left join, right join. Okay. 106 rows. Now right join. Now 122 rows. Why? This will make sense because there are some departments, see, there are these departments where there no one is working, but because we did the left join there, so obviously this being the foreign key, this is as a subset of this is the superset. So because we did right join, so everything from my right table is coming and only the corresponding matches from the left tables are coming, right? This is what the difference between the right join and the left join is. Okay, so another thing is three-way or multiple joins. Now, right now we saw joining two tables. Same way you can join multiple tables. So how do you do? You can do whatever, inner join, left join, right join. HR dot locations on HR. Okay, HR. Okay, locations is LOSE. So DEPT dot location ID is equal to dot location ID. Okay, we didn't pull anything from here. Let's pull something. Okay. So we still get 120 rows, okay? Because now this every department is there in every city. So hence we are getting, even after doing an equation, we are getting all the rows now. Okay, so we joined three tables here. Like this, you can do as many tables as you want in queries in workspace, in workplace. You have joins with 10, 12 tables, okay, because data is at a very normalized form. So you have data in a scattered way or a distributed way, to put it more properly, in distributed way. You can also put conditions, okay? So you can put where filters, you can put or filters. So here you can put and then you can just put in the manager ID, for example emp dot manager id is equal to, okay, like this you can see.